Hey everyone, welcome back for part 6 of my Roguelike and Godot series for complete beginners. Today we're going to be cleaning up some of the code that we've made. I wouldn't so much call this bug fixing, but more just like cleaning up a little bit of the mess that we've made. As we noted last time, there's a couple problems with our arrows. They don't continue on past where they were originally sent to. I don't think that arrows should be physically colliding with the enemy as well as our player. Our arrows need to despawn after they've been in the world for some amount of time, so that way we don't infinitely spawn them and run out of RAM. And I also think that if our arrows get stopped on like a rock or something, they should despawn. Also, I don't know if you've noticed this, but our enemy at the moment, if you walk repeatedly in and out of his attack radius, he will just keep swinging at you even though he's on cooldown. I think we should just take a little bit of time and try and apply some quick fixes to each of these to get them working how we want them to. Before we get into that, you'll probably have noticed that Godot 4.5 has come out, which is really cool, comes with a lot of exciting features, and we're probably not going to be touching any of that, and we haven't used anything that's directly impacted so far in our project. So don't be worried about updating to 4.5, just go ahead. Everything should go smoothly. If you end up running into any errors, I'm sure you can Google them, go to Reddit and see like why certain functions are throwing these errors. But I was able to upgrade mine to 4.5 with no issues. For our first thing, I want to make sure that our arrows will continue to fly in the target direction. As you can see in game, they seem to like land in the ground, but they're like jittering back and forth. It might be a fun idea that once they reach the target chords, that maybe they stay stuck in the ground for a certain amount of time and then like slowly fade away. Implementing that shouldn't be too hard, but to stay on theme with what the original Archero is like, I'm just going to have the arrows fly indefinitely. Before I tell you why, I think you should try and pause the video and look at the script and try and be able to figure out why our arrow does not continue to fly and instead get stuck in place. This one might have been a little bit tricky, especially if you've never done any programming before, but you'll notice here in our physics process function, which you'll see is now highlighted yellow. This is new to 4.5. If your function is going to have a warning to it, it's going to highlight it yellow. The warning of this is that we're not using the argument delta in our function, which is totally fine and it will not cause issues. Sorry, that was a sidetrack. The issue is that we are setting our direction every frame. However, the point that we're setting our direction to does not change. So when we shoot our arrow, it is given this initial target that it's flying to. And that has a specific point on the map. Let's say it's at like the exact middle of our map. So every frame, it gets a little closer. And then once it finally makes it, it'll probably go a little bit past it because checking 60 times a second, it's never going to land exactly on the point. And then it's going to recalculate the direction going back down, backwards to that point, and then recalculate, go back up, recalculate, go back down. So we probably only want to calculate this initial direction once, unless this is going to be a heat-seeking arrow. In this case, we should just be able to move direction to ready, and we'll have the result that we're looking for. But make sure you put it after we assign target position here. We're also going to want to declare direction up here in our global scope so that our physics process function can use it. And I believe that our direction is of type vector2. Now, if we go ahead and test it, you will see that our arrows will largely fly indefinitely, but they will reach our environment wall here at the very edge where the player is not supposed to be able to cross. And we probably want them to vanish at that point. If we wanted, we could separate our rocks from our water in terms of our collision, because right now those are all defined under our environment collision layer, so that our arrow would stop on the rocks but still fly over our water collision, which actually thinking about that, we need that to happen in case our guy wants to shoot over a pond. So what I think we need to do for that, let's go ahead and edit our layer names. I'm going to change environment to water. And then I'm going to add in a doodads layer, which is where we would put rocks or trees or anything else on the map that we might collide with. Now I want to just go ahead and update that in each of our characters, that we don't want the arrow to collide with water, but we do want it to collide with doodads. Our swordsman, make sure you're actually editing the swordsman collision and not his player detector area. We want him to collide with both water and doodads. And then we also want the player to collide with water and doodads. And then in here, I'm going to turn off, I don't want the swordsman to collide with arrows. So I'm going to go to my arrow and I'm going to turn off the fact that he is colliding with player and enemy. And then what we can do is we'll put hurt boxes, and there'll be areas around our enemy and our player, and we'll have those keyed to look for projectiles. And then we can detect when a projectile enters it, what we do with it. We also need to make sure that our rock is now not set to environment, but set to our doodad layer. Now, if we go ahead and test that, we should find that our rock will collide with, or our arrow will collide with rocks, but it will go over our bodies of water, and they will go on indefinitely past that. So now our next issue is that all these arrows that are going to be flying away indefinitely will continue to spawn indefinitely and eventually fill up our computer's RAM and stall our program because of a memory leak, basically. So we need to have our arrows despawn after a certain amount of time. Now, anytime that you want something to happen after a certain amount of time, we're going to be using a timer. Let's go ahead and just add one to our arrow. I'm going to call this despawn timer. And I'm going to go ahead and connect our timeout signal to it. And at the very end, I am just going to have us call a function called queue free. What this does, there is a method in the game just called free. And this will free it from the game. It'll free it from memory and basically just delete it from existence. The reason that we use queue free instead of free is because free will just happen immediately as soon as you call it. But we don't usually want that to be the case. Like, the reason that we handle all of our physics in physics process is because the physics engine is very finicky and needs everything to happen in a sort of expected, predictable sequence in order for everything to work out okay. So if we take a physics item and just remove it from the game, the physics engine will totally flip. So instead, by doing queue free, we queue it up in the engine like, hey, the next time that you have a good opportunity, just get rid of this. And this is going to happen, like, as far as the player and you're concerned, it'll happen immediately. But it might be like in game, like a frame or two later than when you actually called it. So now, as it stands, these things will basically just despawn immediately because they're only going to last for a second. So we're going to set this to one shot because we only want this to happen one time. And we want this to auto start, meaning that it will start as soon as the node enters the tree. I think that based at the speed that our arrow flies, 15 seconds would be more than enough for it to shoot from one corner to the other and still have plenty of time to fly away from the screen. And we can actually go in and test that by just running to the bottom of our map, ripping one at our enemy, and making sure that 15 seconds will be enough time for it to fly away. Perfect. And then if you want to actually test and make sure that these are disappearing, in your editor, you can flip over to remote here, and this will give you a live view of how your scene tree is going. So we can look in our arrow holder. We see that as our player is standing still, he's spawning new ones, but then they're disappearing because the oldest ones are expiring. Last on our cleanup list for the arrow, we want our arrow to despawn if it hits a rock. I can think of two ways to do this. A sort of janky but one-line solution to fix it. You could just say that if the velocity is ever lower than 1 pixel a second or whatever, you could just despawn it. Because we know that if an arrow is ever flying that slow, we know that it has hit something that it shouldn't. But I'm also thinking about if, I don't know, our heat-seeking arrow would have some sort of curve or something, its overall speed might actually be kind of low, so maybe it would accidentally despawn if it's trying to curve around. So we should just instead try and detect collision with the rock. Now, if we go into our character body 2D, I see that we've got a function called getSlideCollision. And what this will do is it will return a kinematic collision which contains information about a collision that occurred during the last call of move and slide. And since there could be several collisions happening at the same time, it looks like it maybe returns an array. There's a pretty neat example here where it shows them iterating through these collisions, getting your slide collision count and then going through each one. And so then what we could do is go through each collision, and then you can use this function collision, which belongs to our kinematic collision.getCollider, and that'll get the actual object that we collided with, and we can say, hey, if that collider is a doodad, then despawn. And since it says that it happens from the last call of move and slide, something tells me that we need to run this process after our move and slide, because the very first time that we run our program, no move and slide will have happened yet if we try to run it up here. So we need to actually have a move and slide happen, and then we can sort of analyze the information from it. We're going to say, so for I in range, and then we're going to say get slide count. And then we're going to say that bar collision is going to equal our get slide collision, and then I will be our index. And then we're going to say if collision dot is in group, oh yes, if collision dot get collider dot is, and then I want to make sure that we have a doodad group actually assigned or something. Okay, no, so let's go ahead and create a doodad global group, and we'll make sure that our rock is assigned to it. And if we ever put any trees or anything like that in, we'll just have to remember to assign them to the doodad group. So if whatever we collide with is in the doodad group, then we want, oh, not queue reader, we want to queue free ourselves. So now if we go ahead and test that, we can see our arrow fly into a rock and it will disappear. So again, just because this was kind of complicated, what we're doing, we are using a built-in function in our character body 2D called getSlideCollisionCount. This will tell us how many things that we have collided with in the last frame. This is something that our character body 2D is already keeping track of for us, and this is just getting us access to that information. Then what we're doing is for every single thing that we collided with, which in some cases might be 0 and it won't run the rest of this at all. But let's say that we collided with, you know, a rock and an enemy at the same time. We're going to go through each of those collisions, and we're using I basically as an index, and we're accessing the first thing in an array, the second thing in an array, third thing, right? And then we're taking that collision and we're getting the collider. So collision is of type kinematic collision, and kinematic collision has a property which is its collider, and that is the actual game object that you are colliding with. In our case, that's either our swordsman, our player, or our rock. And then what we're asking, and there's many ways that we can check if this is something that we're interested in. So if we get that collider, we can be like, okay, if collider dot is, or if collider is player, then because this is class name player, it will check, is our collider of type player? Then we could have something happen based on that. In our case, I just want to know if what we're colliding with is one of these doodads on our map, which is why I did this is in group doodad check. So this won't happen if we collide with the water or the enemy or whatever, because they're not in the doodad group. And then only if we hit a doodad, we're going to queue free, or in other words, remove the object from our memory. Then we're going to go ahead and finish up with an easy one. I'll demonstrate here. When our enemy gets in range, remember, he swings, he stands still, and he comes at us again. If we keep running back and forth in here, before he has the chance to come off cooldown, he will just keep swinging at us. And I don't want that to happen. I want him to swing at us, and then I want him to sit there and think about it before he can swing again. I'm also noticing a separate issue where if we stay in his area, he's not going to swing at us again. So we also need to correct that. So making sure that he doesn't swing at us again and again and again if we keep walking in and out of his range is actually really easy. You'll see in our function on area body 2D entered. This, remember this, our area 2D is what we are using to detect if our player like walks into our range. And so every time that our player is walking into that range, we're just saying that if the player is what walked into range, we're swinging at it. And we need to be a little bit more particular about whether or not we're going to swing at it. So we have this state machine here that we kind of started using where he's either running, mid-attack, or he's idle and sort of on cooldown. So I think we only want him to be able to attack if his state is run, because that's when he's sort of chasing for the attack. So if we also just set this condition here, if the player walks in and we're ready to attack, then do the attack. So I'm going to say if it's the player and current state, not 3 R's, current state equals state dot run. And we want to use the double equal sign because that's the comparison operator. So now that'll prevent the enemy from just swinging at us every time. We can go ahead and test that too, just to be sure. Yeah, perfect. So now we're running into the issue that the enemy won't swing at us again if we stay in the area. I think we can do something with our timer here. So remember that once we swing, our animation player puts us into an idle state and starts this cooldown timer where we're going to sit in our idle state, and then when it runs out, that's when we go back into our run state. So I think what we can do is we can keep a variable maybe that says like true or false player is in range, and we can track that when the player enters and leaves, player is in range. And then when our timer runs out and we start back into our attack stance, if the player is still in range, then do another swing. So again, to track that, I think we're just going to make a variable. I'm going to call player is, maybe just player in range. And I'm going to set this to a false bool. And then in our on area body entered, if it is the player, then I want player in range to be true. And I'm actually going to break this up, and I'm going to say then also if, oops. This will effectively work the same way, where we're saying if it's in the group player, then go ahead and put it in range. And then, and if we're in the run state, go ahead and do our attack. So now we also need to track when the player leaves this area so that we can know whether or not we should swing. So let's go ahead and track body exited. And on body exited, we're going to say, again, if the body is in group player, it's capital, then we're going to say player in range is false. Now, on our timer timeout, we're going to say if player in range, animation player dot play attack. Otherwise, which is written as else, we want our enemy to run. Now, if we go ahead and test that out, we can see that our enemy will swing at us multiple times. If we leave, he will start to chase us. He'll start swinging again. And if we go in and out, it'll look like he's re-swinging at us, but it's only because his timer has reset. So with that, I think we've got a lot of our game working a little bit more how we want it to. I think next time we'll go ahead and start working on both the player and the enemy taking damage from each other's attacks. Thank you guys so much for watching. I hope that it was helpful to see kind of how these quirks can pop up into your game throughout the development process, and sort of how you can go in and address those. If you're interested in continuing along with this series, I highly suggest that you subscribe to this channel, because I don't think in any other way YouTube is actually going to recommend my videos to you. If you found the video helpful, please just go ahead and drop a like. I know it seems like a small thing, but it does help the channel. I look forward to seeing you guys in the next video. Take it easy.